Hello everyone, I welcome you all to another video in which we will learn how we can interface 7-segment display with Arduino. So let's get started. The first question is, what is a 7-segment? We have all seen devices like this in many applications around us and in many consumer electronics. So first of all, a 7-segment display, this is a type of electronic display used to represent numbers and some letters using 7 individual segments. If you look carefully, here we have A, B, C, D up to G, total 7 segments to display a number or a letter here. There is also another segment that is called DP, a point. Including that, it would be a 8 segment. So basically, this is known as 7-segment. This 7-segment, each segment can be individually controlled to create the desired numerical character. Let's say you want to create 1. For that reason, you will have to turn on this B part and C part, that is B segment and C segment. Both of these will create the effect of turning 1 on the display. The 7-segment, this comes in two configurations. The first one is common anode and second one is common cathode configuration. So this device, this could be a common anode type or common cathode type. If it is a common anode type, all the anodes are tied together and connected to a positive voltage source. That means each segment of the 7-segment is one kind of LED. And we know LED has two terminals. One is anode and another one is cathode. Like this picture here, all the anode terminals are connected together and connected to a ground. This is called common cathode. Like the next one, in common anode, all anodes are tied together and connected to a positive voltage source, while in common cathode, all cathodes are tied together and connected to a ground. So if these anode terminals are connected to ground, this is called common cathode. If it is connected to a 5-volt supply or positive source, then it would be called a common anode type. So remember, whenever you are trying to program for your 7-segment, you need to first find out what type of 7-segment is that. The next point is the 7 segments are usually labeled A, B, C, D up to G, as we have mentioned earlier, and each one presents a specific part of the digit or character. By selectively turning on and off these segments in the correct combination, you can display any digit or character on the 7-segment display. And finally, these 7-segment displays are commonly used in digital clocks, calculators, various digital instruments, and as output devices in microcontroller and Arduino projects. So this is one kind of display module. Any project that includes displaying any numerical number or any character, we can use 7-segment for that purpose. Here's an animated display. You can see if you want to turn on 0, you will have to turn on these segments. For 1, this, and similarly up to 9. All these digits you can show turning on and off certain segments. So now we will see how we can program for this sort of segment in OQE. First we will learn how to turn each segment individually, then we will create our own user-defined function for this 7-segment. So this video is going to be interesting because here we will be introducing some new programming concept like user-defined functions, how to create libraries, and etc. So let's see how we can do that. Let's jump into OQE and create a new sketch from OQE platform. Okay, so from the part of library, we will select 7-segment. We have several types of 7-segment at their library: single digit 7-segment, 4-digit 7-segment, and 7-segment display with a driver. So we'll learn one by one. Let's take this one, and notice here that whenever I am pressing on this 7-segment, they are giving me an option. The first thing is about color. You can choose the color here, or you can choose what type of 7-segment you want to deal with. Like if it's a common anode, then you will have to supply ground for each pin, or if you are using common cathode, then you will have to supply positive volt to each of these pin. So let's say we are using common cathode. Now what will happen, let me show you using some dummy source and ground. Let's bring in a VCC here and bring in a ground. Okay. I will now try to introduce the concept of 7 segment and how we can turn on and off each segment. So also bring a resistor. So if you put your cursor on the segment pin, you will see we have common pin here. This is G segment, F segment. This is common A, B, then DP, C, COM, D and E. So as this is a common cathode, we'll turn this common terminal to ground. Now if we take this positive source to A terminal, the first segment will turn on. So which one is A pin? Notice here, this pin, this is the A pin. So if we connect it to positive voltage source and the common terminal to ground, it will turn this 7 segment. Let's see. So this is the A segment and it has turned on. Similarly, let's say you want to write 1 here. That means this is A, B, C. So you need to turn on B and C segment. For that reason, what we'll have to do, we'll have to connect B and C. So this is C to positive supply. Now see, we have turned on 1. This is as simple as it looks. So now let's use Arduino instead of this additional voltage source and ground, and we'll turn the segments programmatically. So let's do that. I'll delete these wires. Okay. Also, let's get rid of this VCC, the ground. Okay. So let's connect all the segments serially to our digital pins of Arduino. We'll connect A pin to resistance to pin number 2. To save time, I will just complete the connection quickly and get back to you. Dear viewers, I have connected the wiring. To save the time for the video, I have just made it shorter. So let me tell you what I have done. I have taken A, B, C, D, E, F, G, all the wires serially and connected to pin 2, 3 up to pin 8. So all those pins has been connected sequentially, and finally this is the ground pin for us. This is common and also this is common. So connect any of the common pin, let's say this one. Bring the common pin and connect it to ground. I'm making the color of this wire to black so that you can understand it better. Okay, so I hope you got the connection, how to connect it. If you want to show the dot point also, you can bring it also here. I'm just skipping this for now. All the 7 segments of the module, 7 segment module has been connected to our Arduino through our resistor. Now let's see how we can program this. This is a very basic program. So for that, we'll define all the pins from pin number 2 to pin number 8. All these pins are output pins. So for that reason, in void setup, we'll write a for loop here. We already have seen how we can use for loop. To use for loop, we need to write first for, then within the first bracket, we need to initialize a variable, like here integer I is equal to 1. Then we need to put a condition. This condition will fix how many times the loop will run. Like here I is less than 5, this is a condition. Then finally, an increment or decrement operator, we need to put it here. So with this format, we can use a for loop. Now using for loop, let's define all our pins from 2 up to 8 as output pin. For that, we'll first write for. We'll initialize the variable integer I. The starting value is here 2 and up to 8. So for that reason, we'll start from 2, I less or equal 8, I plus plus. So this will run the loop from 2 to 8. Then pin mode. In pin mode, first we'll put I and then as output. So this will turn all the pins from 2 up to 8 as output pin. Now let's see, in void loop we want to turn on digit 1. So for that reason we'll have to turn two segments here, this B segment and C segment. So let's do that. This B segment, it has been connected to pin number 3, and C segment, this has been connected to pin number 4. So just to make it more convenient, let's define all the pin at the beginning of our program so that we do not have to trace again and again. Here we have defined all the pins, A pin up to G pin, sequentially from 2 to 8. This will make it convenient for us to define the segment when we are using it for digits. So let's say we want to turn on digit 1 here. So for that reason we'll have to write, so digital write, then we need to define the pin. We need to turn on this B pin and C pin. So let's say B pin high, and let's copy this and edit for C pin. So we have used B pin with 3 number pin and C pin with 4 number pin. With this 2 line of code, this will turn on 1 digit here. So let's see. You can see the digit has been shown here. Similarly, we can write the program for all other digits. Now, before going into further programming, let's introduce a new concept which is called switch structure. So this is similar to if-else conditions, but in a more structured manner. So the switch structure, how this works, first we'll have to write switch, and within the bracket, we need to put some value here. This could be a fixed value or a string also. So for now, as we are working with 7 segment display and we want to show 0 up to 9 value at the 7 segment. So that is why for our case, this will be digit. So switch digit, the digit value, this could be 0 up to 9. So if this is 0, then in between the switch second brackets, we will create some case for each digit. Case 0 will work for 0 digit. Case 1 will put some code to show digit 1 at the 7 segment display at the case 1. Similarly, up to case 9, we'll have total case 0 to case 9, total 10 cases here. After that, there will be a default case. So this is only if none of the case above works, only then the default case will work. And with each case, we can also include a break statement here. So with this structure, we'll program for 7 segment display digit showing. And also we'll use user-defined functions. So let's see how we can do that. We will create a user-defined function here. The function, how we can define that, we need to write void. Then you can give any name. For us, let's say display digit. This is the name of our function. And within the function, we will pass a parameter that is digit. So user-defined functions are like this. Let me show the working of the program first, then I will explain it. Let's say for digit 1, we will put the code here and we'll call this function from here. So digit display, we will call this function with 1 and it will run this block of code and show the display here. This is outside of void loop. Remember that. This is another function and it is called user-defined function. Let's see. Whenever we have called display digit with 1 digit, it has come up to here. And within the functionality of this display digit, we have just introduced 2 simple statements, digital writing for 1 digit. So that's why it's working like that. Now what we will do, we'll implement switch structure here, and whatever digit we'll put here, the digit will be shown in the display. So for that reason, we will first write switch. Within the first bracket, we'll write digit and we'll create cases here. So first case is case 0, and at this case, we'll write the code for 0 digit display. So here you see, for 0 digit, we'll have to turn each segment on like A up to F except the Z. That is why Z pin we have turned low, other pins we have turned high. Let's write 0 here and see if it works. So you can see it has turned on the 0 digit. Similarly, we will write cases for each digit separately. We have introduced code for each digit, like case 0. This is the code for case 0. Then we have written case 1 with break statement at the end, case 2 with break statement at the end. Similarly, we have written code up to case 9 with digital writes, and the last case, if none of the case works, then the default case will work. In the default case, we have turned all the digital pins to low. So this is how we can use switch structure to create cases, and accordingly our display will be shown here. Let's say if you want to show 6 digit here, just write 6. It will come up here with the digit 6, and 6 case we have written it here. So according to this case, the segment will show 6. So let's see. You can see 6 digit has been shown here. If you want to change the color of the 7 segment, you can do so. You can change any color here. So you see the color has been changed. Okay, now if you want to show digits sequentially, let's write a program for that. Let's say we will use a for loop, and we want to initialize the I at 0 so that we can show 0 digit also, I plus plus, and within the bracket or within the loop of for loop, we will show the digits one by one. So instead of 6, we will put I here. What will happen here? It will start at 0 and run code for 0 digit display. Similarly, I will be increased to 1, 2, 3 up to 9, and all the digits from 0 to 9 will be shown here. We need to put a delay here. Let's put a delay of 1 second. So let's run the code now. 0, 1, 2. Isn't it interesting? So in this way, we can write code for our 7 segment display and show digits as per switch structure. Obviously, the code has got a little bit long here. Like we have written 135 lines of code for this program. We can make it more cleaner if we use our own library. So create our own custom library or user-defined library. We'll first go here and create new file. Give it a name like my7segment.h or something like that. Whatever you want, just give it a name. Now you can move all the portion of the code from here to your my7segment.h file. So let's bring the cases also. So now this void display my digit, we have moved it from here. We have brought it to my7segment.h. So whenever we want to use this function display digit, we will just include this library and call this function. Let's see how we can do that. We'll first include the library from the top of the program, and we'll use apostrophe comma here, include, and the library name is my7segment.h. And as we have added it here, we can use any of the functionalities or any of the functions defined in this my7segment.h. So this display digit, we'll just call it here display digit I, and it will go back to this file, search for the cases and do the action accordingly. Let's see how we can run this program. You see, the program is not in this file, but as we have added or included the file, we have accessed all the functionalities defined here in this file. So this is a way how we can define libraries. If you want to see how the software libraries work with Arduino default IDE, we can also give you a look for that. So we have come to a locally installed Arduino IDE software. From its case, you can go for include library, or from here go for manage libraries. Here at library manager, you can find whatever file that has been installed on your PC. Click on this type and installed. So you can see this library has been installed at our PC. We have GSM library installed, keyboard, liquid crystal mouse. So if you go for these libraries at your installation directory, let's say, for me, I will go to my documents and from here Arduino, and here we have a folder called libraries. Under this folder, we have all the libraries that we have currently installed for our Arduino IDE. Let's see what are the types of file we have there. So if you go for liquid crystal, from here go for source, you can see for liquid crystal library we have two types of file. One is liquidcrystal.h that we have just created in earlier section, and liquidcrystal.cpp. So basically library for any components comes with these two files. One is CPP file, that is C++ file, and another one is .h file or header file. So whatever functionalities we use for liquid crystal, this has been defined. Let me open it with Sublime. So all the programs related to the liquid crystal library has been defined in this CPP file, and in header file we have all the definitions, we have the function names, etc, etc. So CPP file will hold the details of your functions, like what would be liquidcrystal.home will work. The functionalities will be given in .cpp file, and .h file will hold the function name only, void home. So these two files are required for creating any of the libraries. I hope you got the idea how libraries work. If you look for other libraries also, like let's look at servo library for source, you can also find servo.h here, and let's for Aviator series servo.cpp, servo timers.h. I hope you got the clear idea how libraries work and how you can create one. Basically, two types are related with a library. One is .h and another one is .cpp. For now, this program .h only we have used. This will work fine. But if you have more functions, this is a simple program. If you have more functionalities, more functions, and more definitions, then you should go for one .h file and one .cpp file. I hope you got the idea how libraries work. Also, you can publish libraries. If you create one, you can also publish your libraries at GitHub and other resource sharing platforms. So that's all for this video. I hope you got the idea how 7-segment works, how we can interface 7-segment with our Arduino, how we can create user-defined function for 7-segment display, and how we can create our own custom library for any of the modules we use in your project. So that's a lot of things we have learned in this one single video. I hope you got the idea. So thank you for now. See you in the next video.